Welcome to this explainer. We're going to unpack the absolutely phenomenal scale of India's data center expansion right now. It's this massive transformation where concrete, fiber optics, and advanced engineering are coming together to literally build the foundation of our digital future.
Now, before we really get into it, I want to let this staggering number sink in for a second. $90 billion. That's the estimated opportunity expected to emerge right across India's data center value chain by fiscal year 2035. And hey, this isn't just about throwing up buildings to house a bunch of servers. It's a massive, fully integrated ecosystem that goes deep into adjacent infrastructure, crazy advanced cooling systems, and highly specialized lifecycle services.
So here's our roadmap for today's explainer. We'll start with that $90 billion boom, look at what's driving the digital surge, see how AI is totally reshaping the architecture, touch on the push for green data centers, and finally, look at the very real human resource gap. Let's get to it. Okay, kicking things off with part one, the $90 billion boom and how India is scaling its digital infrastructure. The sheer scale of what's happening right now is just mind-blowing. India already ranks second in the entire Asia-Pacific region, boasting 1.6 gigawatts of operational capacity. But get this, there's another 3.1 gigawatts currently in the pipeline. And the real kicker, an enormous 10.5 gigawatts waiting right now at the land stage. This basically tells us we're looking at a market that is structurally underpenetrated. There's just massive headroom for growth here, as operators scramble to secure sites for sustained long-term demand. And this growth isn't just isolated to one area, it's a massive multi-market expansion. Mumbai is the primary anchor, and it's actually on track to surpass 1 gigawatt of operational capacity all on its own. But we're seeing this energy spill over. Hyderabad has surged up the ranks to become the 9th largest secondary market globally. We're even watching cities like Vizag emerge out of nowhere, positioning themselves as these highly scalable future AI hubs. Which brings us to our second point. What exactly is driving this massive digital surge? The underlying demand here isn't just about real estate. We're looking at a perfect storm of structural drivers. There's this huge wave of hyperscale cloud adoption, alongside really strict local data protection frameworks that literally mandate data has to stay within India's borders. Combine that with the heavy, complex demands of 5G, edge computing, and the massive digitization of the banking and financial sectors. And of course, the absolute game changer compounding all of this momentum, the crazy acceleration of AI adoption. All these converging forces are building an absolute powerhouse of a digital economy. The Ministry of Electronics and Information Technology expects it to jump from $370 billion in 2022 to a phenomenal $1 trillion by 2030. Now, why does this actually matter to you? Well, because every single app you use, every digital transaction you make, every piece of cloud software you rely on at work, it is all entirely dependent on this physical bedrock that is being built right now. Moving on to part three, how AI is totally reshaping the architecture, taking us from simple storage to ultra-high-performance compute. When you compare older legacy setups to these new AI-native designs, it's honestly a total paradigm shift. Traditional data centers, the ones with standard air cooling and basic power setups, they literally just cannot handle the extreme heat and energy demands of modern AI. So we're shifting toward these ultra-dense systems. We're talking advanced chipsets and liquid cooling technologies that require incredibly resilient, low latency, and high throughput networking and storage. Raghavan Viswanathan over at KPMG in India really hit the nail on the head. He said the emergence of AI-centric infrastructure is reshaping requirements across power, cooling, and compute layers. And that summarizes it perfectly. These AI workloads are pushing power density up so high that the actual physical architecture of these buildings has to evolve. It's no longer just about storing data. It's about handling incredibly complex, high-performance computing. So with all that power being drawn, let's look at part four, the push for the green data center, and how they're solving this huge power constraint. Now, in this industry, power usage effectiveness, or PUE, is the ultimate global benchmark for energy efficiency. And if you track this over the last 10 years, it's an amazing technological triumph. Those older legacy facilities wasted a ton of power. They were operating at a PUE of around 1.8 to 2.0. But by bringing in AI-enabled controls, better server utilization, and that liquid cooling we talked about, power waste has plummeted. Modern hyperscale facilities are now pushing PUE values way down, closing in on a highly optimized 1.2. But look, efficiency alone isn't going to cut it. These hyperscale facilities need a massive 20 to 50 megawatts of power to run. If you rely on fossil fuel grids for that, you get a massive carbon footprint. To offset this, operators are aggressively pivoting to clean energy, which is a really optimistic shift for the whole industry. They're jumping into renewable power purchase agreements, setting up captive solar and wind farms, and adhering to strict frameworks like the IGBC Green Data Center Rating System. That system evaluates the whole shebang, from water usage right down to indoor environmental quality.
This brings us to our fifth and final section, the human resource gap and engineering a zero downtime future.
We've got the real estate, we have the cutting-edge technology, and there's clearly no shortage of capital. But if we actually want to achieve these continuous, nonstop operations, we have to ask a pretty important question. Who exactly is running these massive, complex facilities?
Delivering and maintaining this next-gen infrastructure needs a huge pool of specialized talent. And let me tell you, this is creating some massive, incredibly lucrative career opportunities, especially for electrical engineers. We are talking about absolutely vital roles in design, commissioning, and critical facilities operations. To hit that core goal of absolute zero downtime in a hyperscale environment, this elite engineering talent needs a really specific mix. They need core technical chops, advanced software proficiency for all those AI-enabled controls, and deep sustainability skills to manage liquid cooling and renewable grid tie-ins. Right now, a shortage of this specific elite talent is actually what's constraining growth outside of the major Tier 1 cities. So if you're in this field, it is literally an incredible time to jump in.
To help bridge this critical gap, national skilling initiatives are really stepping up. A fantastic example of this is the Data Center Accredited Professional, or DCAP program, run by the CII-IGBC. It's this top-tier national certification that's being rapidly rolled out to train the exact, highly skilled engineering workforce that this low-carbon, future-ready infrastructure desperately needs. It's all about building up industry capacity in sustainable design and operational best practices, ensuring that the talent pool scales right alongside the physical real estate. So, as we wrap up today's explainer, I want to leave you with this thought to chew on. The digital demand is absolutely undeniable, and the capital is definitely flowing. But the ultimate success of India's $90 billion data center revolution, it doesn't just depend on pouring more concrete. It rests squarely on the country's ability to generate reliable green power and, most importantly, cultivate the elite engineering talent required to run it all. Thanks so much for joining me to explore this incredible infrastructure transformation.